Hello, Minnesota. Hey, hey. Welcome to the Hello World Show Live. I'm Spencer Schneidenbach.
I'm Heather Downing.
And we are thrilled to bring you the second live Hello World Show, first one in the United States.
Woo!
Yes.
So, tell me, do you know why we did this show?
Well, yeah, so a little bit about us first. We are a YouTube show. We have a YouTube channel. You can find us at, if the slide was up on, you can find us at the.hw.show, and that will take you right to our YouTube channel. And what we do is we do 10-minute or less interviews with folks about a software development or a related topic, or topic that would be relatable to software developers, and we ask them to do it in a visual way for the visual learners out there.
Exactly. People like myself have a really hard time learning if it's just auditory, especially on a podcast. So selfishly, I wanted to do a show like this. And it's kind of cool, especially for people who don't have a lot of attention spans, to be able to only learn something in 10 minutes. It's a real, dissected way of looking at a topic. So.
Yes, and we decided to do a live show because we wanted to bring the audience in on it. When we do our YouTube recordings, we're the ones asking the questions. But we wanted to bring you in on it. If you had any questions for any of our awesome panelists, you can go to questions.hw.show. Yes, that's exactly right. And you can also find us right here at the.hw.show, as I mentioned. Find us on Twitter at @thehwshow.
Right. So why did we decide to do this show, Spencer?
Well, because we wanted to bring everybody else in on it. So again, go to questions.hw.show. If you have any questions for our panelists as they're giving you their visual demonstration / lightning talk / kind of whatever you want it to be.
And we'll moderate it, so if you decide to be a little silly with your questions, we can weed that out.
Or we could ask them anyways. All right, so we'd love to introduce our panelists, the folks that are going to be presenting to you today. First off is a gentleman who describes himself as a sufficiently advanced technologist and a lover of .NET. Ladies and gentlemen, Mark Rendle.
Next, we have a microservices and security expert, a CIO, and a Microsoft Regional Director, Ms. Michele Bustamante.
Next, we have a solutions architect and information security consultant and Microsoft MVP. Ladies and gentlemen, an Irish man who lives in Norway, Niall Merrigan.
And last, we have the CTO of Skills Matter, a brilliant solutions architect, international speaker, and musician extraordinaire, Dylan Beattie. All right, so first up, Mark, let's see what you can show us in just a few minutes.
Okay. So right up until this morning, I was planning on coming up here and talking about .NET Core RT, which lets you take a .NET Core application and pre-compile it to native binary executables and then deploy that, and you don't need to have the .NET runtime. And it was going to be really bad, actually, because they keep breaking Core RT. And so I was having my breakfast this morning in the hotel, and as I was getting up to go to my room and brush my teeth and come to the conference, one of the people working in the restaurant said, "Oh, did you enjoy breakfast?" And I'm like, "Yes, I did, thank you very much." I went, "Have a great day." And I went upstairs with a big smile on my face, feeling very happy about myself. And it reminded me of a study that I read about, a scientific study, proper science, that they did at a university, where they got a bunch of students to volunteer to do some tests, okay? And they set this up in 2 different ways. So for one set of students, they put paper signs up along a corridor saying, "This way to the test." And then there was just a sign, "This is where the test is," and you go in and you sit down. And then somebody at the front of the room goes, "Okay, thank you, start." And they just started going, okay? And then for group B, right, all the way along as they were going into this thing, there was somebody by the entrance to the building going, "Hi, you okay, you having a good day? Yeah, come on, it's just down there." And there were just friendly people showing them where to go all the way until they got down and they sat down to do the test. And the second group of students, the ones who were welcomed by happy, smiling people and made to feel welcome and important and as though they mattered, unsurprisingly, really, performed a lot better on the tests because they'd been kind of G'd up and made to feel good about themselves on the way in. And I think that this is something that as developers we can forget about an awful lot. One of the reasons that I would claim to be a developer is that I don't have to deal with people so much. I can just sit down at my desk and go, "Don't talk to me, I'm working." And, you know, my customers are the people who use the software that I'm making. And so I never get to say to them, "Hey, have a great day. And it was a pleasure writing this software for you." And you don't even get to sign that. You can put Easter eggs in maybe and stuff. But I'm writing, you could be writing all sorts of different kinds of software. You could be writing games or mobile applications or websites or line of business applications inside a massive enterprise with 100,000 employees around the world. And you kind of forget, in a lot of cases, that software that you're writing is what somebody does all day. They come in, they sit down at their desk, they log in, they double-click your icon, they launch the software that you make, and they do stuff with it all day for 8, 9, 10 hours, and then they lock their machine at the end of the day, and they go home. And depending on how you write that software, I just have a green Sharpie here, so I'm going to draw things in green. Oh no, hang on, here's a black one. That'll do. So yes, and at the end of the day, after working with your software, they might walk out with a big smiley face. Yeah? See, this is all I can draw. I can draw a happy face, and I can draw a sad face. So this is my visual representation. These are the two possible people at the end of the day sitting down and working with your software. And this person, they're going to walk out of the building and they're going to say, "Bye, have a good evening," to the receptionist, and the receptionist's going to start smiling. And then they're going to get to the train and they're still feeling quite good. They've had a good day and they see a pregnant lady. And so they say, "Oh, please take this seat. You need the seat more than me." And so now we've got a pregnant lady who's smiling. And then they get home and they play with their kids because they're not feeling all stressed and miserable and like they need to vent. And so we've got some happy kids. And then the receptionist goes to wherever she's going, and we just get this rippling out effect of happy people that all started with the fact that this person had a good day using the software that you wrote for them. And obviously, on the other side, we've got the person where you didn't really put a lot of effort into making sure that your software worked and worked smoothly and was nice and friendly and clear and easy to understand and did things quickly. The software where you really just phoned it in. And of course, this person's going to go out and he's going to give the receptionist the finger on the way out. And then he's going to pretend he's absorbed in his paper and ignore the pregnant lady on the train. And then he's going to go home and kick the puppy in front of his kids. And the kids are going to grow up to be serial killers because they don't have a good role model. And that will be your fault, okay? That's down to you because your software runs really slowly and crashes a lot, and the buttons are only that big, and they're in dark brown text on a slightly lighter brown background, which is obviously an exaggeration. But no, I just wanted to remind you, I wanted to take this opportunity to remind you that what we do, what we work on, other people interact with. And in a lot of cases, those people might interact with your product for 40 or 50 hours a week. And so please try and take the time to make sure that that interaction helps them to leave their office at the end of the day with a smile on their face. That's it. Thank you.
I'll give it over to the panel to start with questions.
I have a question. Yes. What happens, check, Hey.
Hey. What happens if they don't use your software all day? Does it still have to be good?
Yes.
Okay.
Yes,
What's
because
the percentage of time? What's the threshold that sort of makes the bad day happen?
I would say,
I ran Microsoft SharePoint for 15 minutes in 2003, and I'm still pissed about it.
there you go. That's the point.
That's SharePoint, though.
Even if what you do is just the thing where at the end of the day they have to put in their timesheet. And so I spent 8 hours today doing this with somebody else's software, and then your timesheet software kind of sits there and hangs and keeps them waiting for 5 minutes before it goes, yeah, no, it's okay, I've saved that into the database now. And so they're 5 minutes late getting out. You can never tell how much impact an interaction with your software is going to have. And so just assume that it's going to be somebody's whole evening that you're ruining if something goes wrong, I think is a good rule. Okay.
So, like, how do you get, like, this built into a requirements document that I want my customers or people using my software to be happy and to show that as a business value prop?
As a business value proposition.
Because the thing is, like, the idea of having less serial killers on the road and in life, that you can see that as a government, it's a government thing, you know, less prisons, less happy people, more taxes.
Yeah.
Could you write it in like that?
I'm sure you could come up with a kind of key metric for it. And maybe part of it would be, if you've got a QA department, people who test your software for you, then at the end of the day, you could get them to draw a smiley face on their way out saying, this is how happy I've been today with the software, or this is how sad I've been today with the software, and measure it in that way.
I'm pretty sure that that's what the Atlanta airport does for the restrooms.
Exactly. There you go. Even, just with your actual users, just give them, like the App Store, you have, are you enjoying this software? Please rate it on the App Store. And maybe just randomly every now and then you can pop up a dialog box in your application going, happy, sad, meh, whatever.
Didn't Microsoft do this with their feedback for the new version of Office? You have a little smiley icon on the top.
Is that what that's for?
That's what that's for.
Okay, there you go.
Yeah, I was kind of curious as to how many serial killers you think Visual Studio's co-op made.
Well, yeah, most of the incels probably. Is that too soon? I don't know.
Mark, thank you so much. All right.
Ladies and gentlemen, give it up for Mark Rendle.
That was awesome.
Next, we have Michele Bustamante.
That's going to be a hard follow. I'm already unhappy. Okay, so one color?
You can use as many as you like.
Really?
I think there's a blue one.
Do I have to fumble through the...
I'll get it.
That would make me unhappy. See, there's so many things to observe that make you happy and unhappy. Isn't that amazing? Sharpies.
Another black.
I think that's good. 2 colors will work. Cool. Okay, so I'm going to talk about why event-based architectures for your microservices is pretty killer. And the way we're going to do that is we're going to take a little journey back into SOA for just a moment, not for long, and talk about how we got here. So first, if you think about SOA and its intention, it was that we would have these apps at the enterprise architect level that say this was an ERP, and this was a CRM, and this is whatever. And you know, they're supposed to own their own services, of course, so these are APIs, and all of them do the same. And then each of those APIs, of course, own their data store, and there is complete isolation between the services and ownership in the vertical. The idea there being nothing gets at the data without going through a well-defined contract and a well-defined API. And there are a whole bunch of other rules that we had is the premise of SOA, right? The idea of that isolation between the services. And then with an enterprise architect's view, of course, we could stay pure to this without a problem. There might be many, many, many tables, many, many relational tables, even multiple databases behind here, but they all go through the service boundary and they all go through that well-defined contract. No other folks coming in from the side. Check. However, it was a problem for people doing real software applications because SOA originally in its premises around these rules actually did that for, enterprise architects. So a funny thing happens when you start writing software where it's not an ERP or a CRM, but these are just kind of my apps, right? And I've got these different web apps, and they each have their own APIs, and we're developing those APIs. And maybe I've got customer views and orders and things like that. And the customers and orders have tables, and we try to own it with the API, but we have this problem because there's a relationship between customers and orders. So now I have a dilemma. How do I stay pure to the tenets of SOA? How do I keep that isolation between these APIs and also own their own data and not allow anybody into that data for read or write except for through the boundary? So we have this problem because we're starting to want to do these things at the data level, and we're not supposed to because it doesn't go with the rules of SOA. So the way we got around this was magic, right? We started to build these data services. So the blue boxes represent the data services, and now, yay, I just own that data, and I can happily and freely cross over boundaries from each service to the other services because this is a service tier, and they own their own data. Mission accomplished, except now I have aggregation. I need to get access to this and say I want to show customers and orders and relations between the things. And so now I've got to go through service boundaries only, which means I'm going to have multiple, say, 3, 5 calls. I'm going to have really slow results. And what I really needed was a query that joined things together. Makes sense. It was not designed for this problem. So now we enter in a microservices age. And with microservices, we still have the same rules. We just have a lot more of them. So now I have a whole bunch of APIs, and many more of them, each wanting to own their own data store. And, we haven't really necessarily, gotten rid of the problem and the shame that comes with crossing these boundaries that we would like to avoid. We just have a lot more, and they're smaller, so now they can own a smaller piece of data, which hopefully at least can be well defined behind the API. We still have this aggregation issue. So when we think about microservices with maybe one or more, couple of UIs, bunch of services going through the boundary, and this level of ownership that we're expecting to have, we still have the challenge that we had with SOA. However, we have a couple of differences. And one of them is that in the microservices space, we've also evolved to thinking more about message-based architectures and CQRS and having read and writes as a separate interface into the data, for example, and this concept of eventual consistency. So those themselves are not part of the microservices principle or rules, but they've become a more accepted practice in this era. And so the principles of microservices, while they follow a lot of what we had in SOA, and come over here to make it easier to manage lots and lots of little services, what's become more manageable is the size of the data I own behind the API, the ability to isolate one from the other so they don't overlap in terms of business domain. But we still have something that we need to solve the problem of the data relation, and that's where eventual consistency comes in. So what we're looking for is a way to say, hey, let's take this and produce an aggregated result, because I've got this new UI over here and this new service for that UI, and it's going to look at the aggregate, and now that's a new microservice. So as long as I can get to the state where I have eventual consistency, I will have solved some of this problem. So now we need to talk about, well, that's great, so how does this work if I was going to approach this? And what are we really talking about here, which is not that we've solved the problem of data ownership and the fact that we want to have pure services that don't cross data boundaries, but that we have a more acceptable way to do smaller services that fit in our head, that feel manageable, and that if we could embrace eventual consistency, we can now focus on that problem. So what I'm going to do is flip this over, and let's talk about how we achieve that. And I didn't practice flipping, so let's see if it works. Okay. Yeah, you got to practice. So when we think about an eventual consistency story, one way to do it could be that, I have my applications like this with their services behind. So this is my web, this is my API, right? And this is my data on the back end. And so, if I was thinking about producing some new aggregate, I could come from the data layer and try to do that. and use triggers or something. The problem with that story, of course, is what happens if, a couple of months later, I decide, hey, I want this new view on all of this data. So I need to create this new website that probably has an API that owns this new view, so this magical new aggregate, let's call it. And, I have no way of knowing, like, what happened over here and how do we produce this view, unless I want to somehow go and, look at a snapshot and then build a current state. And then maybe new transactions can start to be eventually consistent. But a better way to do this would be to look at this from a messaging perspective, right? So if I have the messages, then I can replay. So a different approach would be, let's find some room here. Here are my web apps. And let's just say these guys live up here. And here are my APIs. And there might be crossover here. There might be multiple APIs for a web app. There's no rule that that UI has to be one for each. And then somewhere down here, my APIs, instead of going direct to the database, are actually going to do some, validation or whatnot against read stores. And then what they're going to do is produce a message that says, here's what just happened. I created a user. I changed their permission. A user logged in. A user logged out. These are events. And those events are what are going to be basically, in a way, the system of truth of sorts. But what we're going to need to do is project those somewhere so that it produces the data at the other side. And so I'm going to flip one more. And I said I was going to use a few of these. And so what I'm really looking for is this. I have web, and let's say we've got a couple of these. I've got API, and here we go. And I've got messages coming out of API, which I'm clearly an excellent drawer, if that's a word. And ultimately, what I'm going to have are these consumers or projectors that are going to pull from the event store, event hub, et cetera, right? And they're going to be the ones that do the write to the database. And because CQRS is also a common pattern here, probably this guy up here already has some sort of read, API that's being used to call to the read store to get data back. So that's a nice separation as well. So this fact that this is eventually consistent, no problem. This is the guy that's going to read and present data. And now I still have this concept of a pure microservice from all the way from possibly UI, but definitely API, CQRS, read, write, messages coming out, projectors pulling and writing to whatever the target store is. And here's where the fun part starts, where I can say, hey, all these messages still exist. Maybe they stay in an event hub for 30 days, and then maybe we archive, which you can do with one button in Azure with Event Hub. And so what we'll have is a web app and a new API, and I want to produce this aggregate. And how I do that is I create a new projector, and that projector is going to pull from those messages wherever they live and say, hey, I'm going to produce a whole new view across possibly many of these messages, and my eventual consistency story also has a future, and I can get over the idea that I need to know up front what my microservice data relations with other things looks like. Just focus on the service, focus on this vertical being nice and tight and small and fit in your head, and eventually I can project everything, and it's a perfect system. Thank you. Drop mic.
No, come back up. We have questions.
Oh, hi. Okay. I thought it was out of time. I used every second, didn't I?
That was just for your presentation.
Oh.
All right, I'm going to turn to the panel first.
Okay, so in all the rabid kind of purist microservice definitions, each microservice has its own data store and is responsible for that. In this model, would you have sort of one microservice that is able to write to a data store, but potentially multiple microservices that have read access on that data store for things like aggregation?
Nope.
Okay.
I'm producing a new aggregate, new data store from the messages. And this new aggregate data store is called by its new aggregate API, and it owns that. That's my new microservice right here.
Okay, so does the API microservice do the bit where it pulls in the messages?
No, I have a new projector, which, by the way, belongs to this microservice.
Okay.
And it knows what it wants to read,
Right.
which messages, but it's not writing messages, as you note. So it's all about consumption
right,
and
okay.
being able to consume across multiple topics for the purpose of aggregation. Whereas here, this is very pure. No message is ever duplicated across microservice. So you really do have that fits in your head, 20 to 30 messages. Here's my API, my messages, my projector, and my data store.
Okay.
Is there any point where eventual consistency is not considered a good option?
That is absolutely true.
Yeah.
True. Okay, so when we think about, let's talk security.
Yep.
Okay. So if a user is, say, deactivated by a management system, so I'm here and I say deactivate user. If that's eventually consistent to here where I log in, then I have to know what are the constraints of the organization and is that an acceptable metric. Likewise for things like lockout, right? So anything that could affect the state of login, anything that could affect a security flow, we have to decide up front whether that fits it. The way to address that is a couple things. One way is to use things like Event Store, which is where the messages also have persistence here, and the stream is the user, and the user is always current because we always read the stream for any reads. And so for anything security related, we would go direct to the stream to see if you can log in, rather than going to the read store to see if you can log in.
But
so that's event sourcing,
yeah, and
right?
that's where eventual consistency isn't a correct solution for
that particular flow.
Yeah, but it's a thing you need to consider that
Yes.
this is not one silver bullet for all types of
Absolutely,
microservices.
and
Okay.
not all services in your microservice architecture will necessarily warrant having messages. It does add a layer that you're dealing with. What I find is anytime you want history tables and audit and things like that, now you have a place to go to create those also projections. So that's a beautiful thing for compliance. And I find that if you get used to doing this, it kind of fits in general very nicely with large distributed microservice architectures that are already complex anyways. And this gives me tools to do interesting things later, which don't, pigeonhole me somewhere. But you have to take the is eventual consistency okay for X, Y, Z into case. And for those particular cases, you could do things like either event sourcing, where the stream is the actual place you go for those particular requests, or if that's not possible because you're not using Event Store, which does that very nicely, then maybe instead you're going to the actual, you would have to have like direct writes for locking out and deactivating somehow into that service, into that data. So.
We have time for one more question from the audience. Is how do you seed the Johnny-come-lately service aggregate with data that predates the data in the messages?
It can't, because you're going to archive this, and you can also do snapshots at periods of time, whereby you're also not needing to go to the beginning of time for all the messages. So the whole point of it is that you have the messages from the beginning of time, so there's no predating. Now, if you were to start doing some hybrid where this already existed and we had a starting point snapshot and then we introduced messages, then obviously that starting point snapshot needs to live somewhere to produce the beginning of the aggregate snapshot and then play the messages.
Great. Thank you so much, Michele.
All right. Thank you. All right. Next, Niall Merrigan.
That's a tough follow. Oh, boy. Right.
I'm noticing a pattern.
Yeah, you're doomed. All right. So how many of you have been using the conference Wi-Fi? How many of you wondered who else is on it? And how many of you wish you could just kick them all off? So, are you sure you're using the conference Wi-Fi? If you kind of take a look right now, how many Wi-Fi points do you see? I was saying, no, not look physically, look around, mate. Actually on your computer. If you can see all the different Wi-Fi SIDs right now, there's probably in the region of about 3,000, give or take. And that's because of a small little device which I have hidden under here, which is called a Wi-Fi pineapple. Now, sometimes you have to go big. So the Wi-Fi pineapple is a rogue access point. And what it does is it simulates all the SSIDs that you can potentially access and answers yes to them. And what this is about is where if I'm on the same network as you, what can I do? Now, Heather asked me yesterday, says, Niall, is HTTPS enough for all my services? I'm like, no. And let me show you why. Because if we go here, we have you on your laptop, okay? And you have connected to the router here, like that. And that has connected you out to the internet, okay? So far, so good. So you get an IP address, something like 192.168.1.10. And it has a subnet mask, 255.255.255. So it's only 1 and .0. And it has a gateway, 192.168.1.1. It's all common, you've seen this before, which means that the gateway is usually your router, okay? So underneath that, you have a thing known as ARP, Address Resolution Protocol. And what this does is it tells you where on your computer, or where on the network, what MAC address, physical network card, is responding to what IP address. So if you're running Windows right now, you just do ARP -A, it will show you what your router and network address and all the usual stuff. You'll see, like, for example, 192 goes to some 8 octets, right? So I'm also on the computer, on the network with you. And in my case, I have 192.168.1.11. I'm the next one in the room. And I do a quick thing like use something like Fing, or I do, if you've got an iOS device, use Fing, and it tells me what the different devices are on the network. So I go, cool, so that's Mark, and I like Mark, and so I thought, I know what I'll do. I'll help Mark with his internet. So what I do is I send a little ARP request to his computer and say, change the MAC address for 192.168.1.1 on his computer, where it's pointed to. We'll assume it's going to 00 dot the whole way to FF, like that. And say mine ends in .ee, my network, my MAC address. And say, point on his computer, say .1.1 now points to this MAC address. So when the computer goes, how do I get out? It goes, well, you've got to go to the network address, MAC address that ends in .ee, aka moi. And at this point, I am now a man in the middle, because I will then reroute his traffic up here and out. So anything Mark is browsing, I can change if it's over HTTP. So if it's not on HTTPS, I can do HTTP. And he's like, cool, I think I'll go to my bank. Now, Mark's an entrepreneur, well worth good money, you know. The face on that. So he decides he's going to go to mybank.com. And he notices there is the padlock, or the tiny shopping bag. And he goes, great. And it's still, all this is legit, except all his traffic is now posting through me and onwards. And I go, okay, cool. And I quickly check. I don't have to quickly check, but I can. And I find out that this site also responds on HTTP. So it goes through port 80. So it has port 443 and port 80. All right? This is secure. This is not. And what I want to do now is take away, for any request he sends out to the bank, I want it to downgrade the request to HTTP so I can interfere with it. So when he says, I want to send $100, he now sends $100 to his family, and I take $900 just for like a transaction fee. Okay? You know, we're Irish. It's cheap. It's an entrepreneur. And I can do this. And you're going to go, but Niall, how? Because I have another piece of software called Ssl Strip. And what this does, it acts like a small proxy. So when his request comes in for port 443, I go, that's great. I change the URL here, send the request as HTTP. It goes to the bank. The bank goes, okay, I'll accept HTTP just this once. It comes back. I then re-encode it with his HTTPS and send it back to him. He goes, cool, it worked. Nice. It's written by a guy called Moxie Marlinspike, and it's absolutely fantastic. If you want more information, go to DEF CON 17, and he shows this off. But this is just an example where if he thought, like, or the person writing the software who wanted to make less serial killers said, well, they've got HTTPS, it's fine. All the traffic's encoded, you know, it's secure. Yes, it's TLS, as in the conversation between me and the server is secure, but not the information I'm sending over it. So in this case, I can potentially strip it. I can take away information. I can add information because there's no checksum for it. So if the bank had been encrypting information between the two, in other words, just assuming that someone could actually intercept the traffic and remove HTTP, and then says, okay, but the communication then should have be signed messages. It must have a certificate or some other thing. I can't duplicate that. So that's just one way, if I'm on the same network as you, how I can interfere with your traffic. If you run over HTTP, I can change it. I can change DNS. You want to go to whitehouse.gov, I send you to whitehouse.ie. It's the Irish version of it. It's a tiny pub somewhere in the north of Ireland. Now, good old spot. I can send you wherever I want. So if you got to go to Facebook, you get up to Facebook, some other idea, and it'll look exactly the same. If you've been on the conference Wi-Fi here, when you put it up first, it goes, you need to click OK to select, all right? So now if I'm in a man in the middle, what I can do alternatively is I will create a nice little page, which will say, hi, welcome to NDC in Minnesota. We're so happy you're here. To help us improve our services, we have a social media login button. Okay, please put in your Facebook, Gmail, or whatever you would like, and we'll redirect you to the correct site just to verify that you're a human. Okay, and you would be very surprised how many people donate their usernames and passwords to me because people are nice. Now that is just an example if I'm on the same network as you. But if I want to get you onto my same network, I use something like the Pineapple. Your device is being quite friendly and it joins me, and eventually I have the same thing here. I add as a man in the middle. This is why, for example, if you're just relying on HTTPS, this is a very bad thing. If you're wondering, okay, but Niall, how on earth do I protect myself against this? Because it's not really a good talk if I don't tell you just how to attack you, but also not how to defend. Use a VPN. VPNs, especially on open conference networks, means that you are securing your endpoint. So you are going to a trusted server and from there out, which means that no one's eavesdropping you or can be intercepting your traffic. So it's very important when you go to events like this, you have to do that. If you're on an open Wi-Fi and not using a VPN, it is a sign to say, just rob me, why don't you? Okay? So, ladies and gentlemen, be very careful on whatever network you're on. Be much more careful to spot me in the building on the same network. Be also very careful about, for example, if you are working on any network that you don't own or you don't control, assume hostile. It's a very easy way of doing it. It's a little bit paranoid to think about it that way, especially kind of in, as we different places. But for example, airports all the way. If you have iOS, download Fing, F-I-N-G, and just run it and have a little bit of fun of looking at all the different devices that are on the same network as you. You'll find in a hotel who's there. You might find point-of-sale devices. You'll find televisions. And smart TVs are great to play with. You'll find all sorts of manner of things. And it's just because people are just trusting that whatever network they're connecting to, no one can interfere with. All right? So use a VPN. And the thing is, ARP spoofing, there is technologies. I think there's a particular piece of software that Tumble or Trip will actually will notify you if you get an ARP update that's kind of a little bit dangerous. This is also a potential denial of service attack, because if I put enough of this on, I can potentially slow the network down hugely. So this is a really interesting and very simple way of doing it. It's also extremely passive. Your computer doesn't give you any notification if you've changed the ARP table. All right? So I'm done with 19 seconds. Hi.
Thank you.
Right. So now I get the Inquisition. Do you want your money back?
Yes, that would be nice.
There you go.
So you say you use a VPN?
Yep.
Isn't that another man in the middle? How can I tell which? So yes, technically it could be, and there are probably malevolent ones out there. Is there any standards organization or accreditation that I can look for to choose a VPN?
Unfortunately not.
Okay.
Which really, the only recommendation I can give you is if you want the Gurk, he's a zero-day dealer out of UK zero-day dealer that works in Thailand. There's a number of different VPN studies done. Generally what they say is don't have any that belong to the Five Eyes. So that is US, UK, Australia, New Zealand, and is it France, Canada. I think? Canada, okay. Because those kind of a little bit more, not too sure, they have regulations. My preferred is Freedom from F-Secure with Mikko Hyppinen. It just works on everything. But you have to do your research, because some will say, we don't serve any logs, or we don't do any intertampering or anything like that, and then they do a little bit of it anyway. Right?
Okay,
Okay.
thank you.
I have a question.
Yep.
So if you, I mean, obviously, besides sniffing traffic, there's still action that has to be taken, right? So, I mean, you want to talk a little bit to if you don't click and go to that bank, if you check the URLs properly, if you know better than to enter the password and all of those good things, should that not be also a way to protect yourself?
It's, yeah, basic security hygiene. Like, for example, if you go to a hotel and you spot like a machine in the lobby, for me, it's like I go mining. The first thing I do is I check how many people have saved passwords on Chrome in there, and then try and see what they've done, and check the history, and you find all sorts of manner of good things in there. But realistically, with the Ssl Strip, you won't notice the change because it'll look like legit. But you should notice it, but not a lot of people do. Thankfully, Chrome is making it a little bit easier because it does have the big not secure now when it's when something's over HTTP, and that's really something you should be looking for. On being very honest, on any home machine, this is not going to be an attack you'll probably see very often, but it is an attack to be aware of that is very easy to do. So should be very careful, and that is like a small bit of awareness is much more valuable than trying to rely on a whole lot of tech.
Okay, we have a question from the audience.
Yep.
Niall, what should a non-security researcher do when they discover a vulnerability in the wild, like a bank, like a bank vulnerability or something like that, without being called a hacker?
Oh, that is very topical because I just went through that. I can't go to Thailand now for a while. So your first line of defense is, depending on the country of the operation of the website, you can notify the CERT, what we call the GovCERT, the Computer Emergency Response Team. So there's like, for example, there's US CERT, IE CERT, North CERT, all these around the world. And what you do is you notify them and say, hi, I found this, detail what you did, okay? And explain it was not malicious. However, some people do get a bit upset about this and may kind of try and go after you. If you go through the CERT and notify them, the CERT then puts pressure on the particular company or location to get it fixed, and also may work with them to help them fix it. If you go, this is a very difficult thing because the security researchers generally have to skirt the law to find the issue, and when they do, people will say, you hacked us and you broke the law, and therefore you are a bad person, let us sue you. And you have to be careful of that. And it is quite nerve-wracking because I just went through that with a mobile company in Thailand, and they got a little bit upset and threatened to sue me and a whole lot of other things. But everything was done by the book. Unfortunately, people don't like being shown they've made a mistake. The best thing is what we call responsible disclosure. Go to the CERT, notify if they've got security at company and say, we found this. And if they have security at the company, they will be probably more active and being able to respond to you. Detail all your actions and be very transparent about it. And do not, for the love of God, if you find a SQL injection on it, download the entire database and send it to them. That's bad. If you find a direct object reference, in other words, you can go +1, it's literally, that's enough to show a proof of concept. You don't need to download all the customer data to prove how smart you are. You just need to prove a proof of concept. So for non-security researchers like that, make sure that you do everything by the book. Troy Hunt has a very good blog post on responsible disclosure. Recommend you read it. But just go through the CERT as the ultimate starting point, or like something like the GDI Foundation, for example, will give you help with that as well.
Thank you so much.
Welcome.
And finally, we have Dylan Beattie, everybody.
Hello. So I'm actually going to do this section in my alter ego, guys, as, see, I brought props and costumes, as the Masked Avenger. Now, I'm just going to flip back to Niall's sheet here for 1 second, because, and this is completely spontaneous, he drew up here these 3 little pieces of information that we use with IP4 networks. We have the IP address, we have the default gateway, and what's the thing in the middle called? The subnet mask. Why is it called a subnet mask? I'm going to tell you. And I'm going to start off with pizza. There we go. So, what we have here is a load of different kinds of pizza. So across the top, I've got toppings you'll find on pizza, 8 of them. There's a reason there's 8. Tomato, 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 cheese, pepperoni, ham, olives, pineapple, steak, and mushroom. And then down the side here, we got 5 popular kinds of pizza. So the Margherita pizza here, that's your plain pizza. That's just tomato and cheese. Yep. The pizza Romana doesn't have any cheese on it. It's just got tomato, and it's got olives, and it's got mushrooms. The meat feast, cheese, tomato, tomato, cheese, pepperoni, ham, steak. The veggie deluxe, we have tomato, cheese, no pepperoni, no ham, olives, pineapple, mushroom. And finally, down the bottom, the Philly cheesesteak, cheese and steak. The clue is in the name. So let's imagine we've taken all this and we've stored all this in our database somewhere for our online pizza restaurant. And we now need a way that people with particular requirements can find the pizzas from our menu that suit their requirements. And in order to do that, we're going to use these, because these are bit masks. So what we have here, Heather, do you want to take this one? So this is the vegan bit mask. And what I've done here, there are holes in it, so you can actually wear these, you know? They're very versatile. You can take the bit mask, and you can slide it down like this over the dishes on the menu. And basically, if you can see any of these ingredients, it means this pizza is not for you. So, Margherita, vegan, yes or no? No. Romana? Yes. Meat feast? No. Hell no. Veggie deluxe? No. Cheese on it? Vegans don't eat cheese. Cheese steak? Nope. Hold on to that. This is the pineapple allergy bit mask. It's people who can't eat pineapple. So, Margherita? Yeah. Romana? Yeah. Meat feast? Yeah. Veggie deluxe? Nope. Philly cheesesteak? It's fine. There you go. You can be pineapple allergy. Vegetarian? Yeah? Yeah? No? Yeah? No. There you go. You can be vegetarian. And finally, we have the Ron Swanson bit mask, because Ron doesn't eat any vegetables. Nope. No tomato. No tomato. No tomato. Nope. Hell yeah. Cheese and steak. That's all Ron needs. So this is the basic principle. You with me so far? We got this idea that we got this sort of checklist of ingredients, and we got these checklists of requirements. Now, what we're going to do next is we're going to look at how you can implement this using an ancient computer science technique called bit fields and bit masks. So what we're actually going to do, I'm going to just rip this thing off here. There we go. Now, what we're going to do next is we're going to look at how you can implement this using an ancient computer science technique called bit fields and bit masks. So what we're actually going to do, I'm going to just rip this thing off here. There we go. Pineapple is going to be 4. Olives is 8. Ham, 16. 32. 64. 128. Yeah? Because what this allows us to do is we can take, say, our Margherita pizza, and we can take each of these values, and we can treat those as the bits in a byte. We've got 8 bits in 1 byte, so we can go, okay, so a Margherita is 11000000, which means it's 128 plus 64, which is, Mark Rendle, 192. So Margherita is 192. The pizza Romana has just got tomato, olives, mushroom on it, so it's got a 1, a 0, a 0, a 0, a 1, a 0, a 0, a 1, which means we've got 1 plus 8 is 9, plus 128 is 137. So we just worked out a way we can represent any possible pizza with these 8 ingredients using a number between 0 and 255. 0 is plain pizza with nothing on it. 255 is the works, full house. You've got everything on there. We can do the same thing with our dietary requirements. So we're going to say, okay, the Ron Swanson pizza mask we're going to represent down here. We're going to say Ron is 1, 0, 0, 0, 1, 1, 0, 0. Which gives us 128 plus 8 is 136, 137. Now, when you're poking around in programming languages, you'll discover these things called bitwise arithmetic operators. In most languages, the bitwise OR is a single pipe, and the bitwise AND is an ampersand. And what those actually mean is we're going to take the Ron Swanson thing here. So let me flip onto a fresh page. Actually, let me rip that off. So we got the Margherita Pizza here, say, or the Romana Pizza here is a 1, 1, 0, 0, 0, 0, 0, 0. And this thing here, the Ron Swanson, is a 1, 0, 0, 0, 0, 1, 1, 0. What the bitwise operators do is they take each pair of bits in the input, the two input numbers, and they just perform a bitwise AND or a bitwise OR. So bitwise AND on this, 1 and 1 is 1, 1 and 0 is 0, 0 and 0 is 0, 0, 0, 0, 0, 0. By combining the bit mask representing the pizza with the bit mask representing the dietary requirements, if we get a number that is equal to 0, it means it's fine. It means this person will eat that pizza. If we get a number that is not equal to 0, it means this person can't eat that pizza. Now, the advantage of doing this is it is blisteringly quick. If you have a bunch of people, customers, in your database, in, say, Microsoft SQL Server, and you have a bunch of pizzas, and you've represented everyone's dietary requirements using this 8-bit field, and you've got the pizza as an 8-bit field, you can do select star from customer join pizza, where dietary requirements bitwise AND ingredients, and it's blistering. It's one of the fastest index joins you can possibly do. So you can instantly get a list of all the different kinds of pizza that any person can eat, just using this idea of turning these checkboxes and bit flags into an 8-bit number. And the reason why, if we go back here to the reason why this thing is called a subnet mask is when Ethernet, when IPv4 is trying to work out whether a network packet can go straight from my laptop to Mark's laptop, or whether we need to send it to the default gateway, the way they do that is they take this thing here, the subnet mask. So 255 looks like this: 1111111 dot 11111111 dot 11111111 dot all the zeros. And then we're going to take the network address that we're coming from. We're going from 192.168.0.10, which will be, let's assume that's 1111. What? 1100. What about 168? But the point is, what we end up with is when we apply this mask to that number, the source address, and we apply the same mask to the destination address, if the results are the same, it means those devices are on the same network, and you can get there without routing via the default gateway. And if the results are different, it means the device you're trying to get to is not on your LAN, send the traffic to the default gateway, send it out of the building. So that is why I'm wearing a mask. That's why it's called subnet mask. That's how you can order pizza using bitwise arithmetic, and that's what the single AND and the single OR in languages like C and JavaScript and C# actually mean. Thank you. I shall take the mask off now.
Stay in costume till the end.
I am.
That's a question.
If you like.
All right, panelists, do you have any questions?
At the risk of appearing enormously dense,
Don't
who
worry,
is
we will.
Ron Swanson?
He's a character from a television program
Okay,
called Parks and Recreation.
You should watch it.
You should watch it. You'd like him. He hates people.
fair enough.
He's the source of the quote, I shared an office with a guy for 3 years and never learned his name. Best friend I ever had. We still don't speak sometimes.
Okay. I'll watch that then.
Yes.
Is it on Netflix? Sorry, that's
it's on
two
Amazon
questions.
Prime Video in the
Awesome,
UK.
got that.
So, and yes, I did actually make masks that we can wear as masks if you need to be, well, obviously yours isn't going to work.
Who needs depth perception?
Are there any questions?
Can I have a meat pizza?
You can have a Ron Swanson bit mask,
Okay.
handmade.
Okay. I guess that's kind of like pizza. No, I really don't.
So with bitmask operators, then the larger the in for example the subnet mask, if you've got 255.0.0.0, that's like what is it? 64,000. No, how many addresses is that?
So you get there's three kinds of common subnets.
Yeah.
There's class A, which is 255.0.0.0.
Yeah.
And what that basically means is that the 0.0.0 means there's 255 times 255 times 255 devices on that local network, which is very, very good if, I don't know, it's never very good.
No, not that big. No.
But there's still like Sun Microsystems have a class A internet network. They have like 17 dot everything in the entire world. 17 dot anything belongs to Sun Microsystems. You can't get them anymore because the address space is too contended.
No, it's run out of space now. Yeah,
it's run out of space.
Yeah,
They're all
before
in
it's run
use.
out. Do they have the same? Do you have? No, just thinking of bitmap maps. Do they have it for IPv6?
I don't know.
Okay.
I don't know how routing works in v6.
Okay, I can't even remember.
It's only been just about to take off since I was at university 20 years ago, and I've still never needed to set it up with anything.
So is there any places where like you've actually seen bitwise operations working or like in code that you have?
So the company I used to work for, we have a system that sends job notices to actors. And the actors go onto the website and they tick a whole bunch of boxes. These are the territories where I want to work. These are the types of projects I'm interested in. These are the pay categories that I'm interested in. And then when somebody puts a job on the system, we get them to tick the same boxes. We store that in the underlying system as a bit flag. The system sends about 50, 60,000 of these things an hour on a good day. And so we use that to do a really, really optimized lookup on working out which jobs need to be included in which emails, which get sent to which people. The secret with doing this is you put it in the database, name the field something like production budget bit field. Otherwise, someone's going to look in it and go, production budget, 127, I wonder what that means. And they will waste a week of their life looking for the lookup table that all of these numbers come from, and they will not find it. The other thing, of course, is if you add a ninth ingredient to your pizza options, the whole system is going to crash and burn if you're using bytes. So do some planning in advance. Don't use it for something where the lookup list is likely to grow. Because you can go from 8-bit to 16-bit easy, 16 to 32, 32 to 64. 64 to 128 is a bit of a stretch, but SQL Server does have 128-bit integer fields. You go beyond that, and suddenly you're in a whole world of pain because nothing supports 256-bit numbers natively. Yet. And
Thank you, Dylan.
That's not a racing game I want to play.
Awesome. Well, we just have one question for all of you to answer.
Okay.
What, if any, disruptions do you see in how we approach application security?
What is any disruptions or? Okay.
Like, which one should we take seriously? There's so many that happen. Like, which one should we go, we should fundamentally change the way that we are approaching building these?
So there is, it sounds kind of bleak, but I sometimes wonder how many companies are only profitable because of all the stuff they're supposed to be doing that they're not.
Yep.
Almost any organization you go into, you look around for a little while, you'll find a team that's like, they haven't hired that person yet, or they don't know that they have vulnerabilities here because the people working on the software have never encountered that kind of vulnerability in the wild. There's compliance issues. There's companies who maybe aren't 100% compliant with new things like the GDPR, this data regulation we have coming in Europe. And it kind of worries me because, they're not doing it to be evil and they're not doing it to be manipulative. But in a lot of cases, I think the gap between doing everything you know about and doing everything you actually should be doing might even represent the difference between staying afloat and going under for a lot of small companies. It's a big challenge. The one thing that I draw a lot of strength from is it's now becoming increasingly rare for companies to roll their own solutions. When I first got into this, it was really common. You'd find a team, they built their own servers, they ran their own network cable, you hosted on-premise on machines that you built and you patched, or you told your boss you'd patched, but actually you hadn't patched it yet and you were going to do it next week. Even teams doing things like rolling their own crypto algorithms. Yeah. And nowadays, it is actually cheaper and easier in almost every case to host with Amazon or Azure or Google App Engine. Good, strong, secure crypto libraries are available for every single platform. You just download one, plug it in. You don't have to roll your own. And so I do think that it's becoming increasingly easy to do the right thing just because that's the pit of success.
We're currently in what we kind of have like the Volvo moment. Volvo, when they released the 3-point security harness, the entire industry rebelled against it, and they were offering it for free. So you can imagine driving a car without a seatbelt right now. You'd be just going, what? No. And now, if you buy a car right now, it's got airbags, it's got side bags, it's got everything. It literally, you can throw it off a cliff, and it'll just go, I'm good, and walk on. But we are getting to that point where security is now becoming a thing we must think of, even for people where they may have been doing the dark matter stuff. What I'm hoping is going to happen is what's happened with UX over the last 10 years, where it's gone from being, oh, this would be really handy to have, to now becoming nearly how you start a project and start anything. You go, how is it going to look and feel? Like, to give Mark, how is it going to make our users feel? I'm hoping that with security, in a lot of these cases, they're going to go from the UX, or the kind of UX stable, and say, how are we going to make this thing secure without restricting our users or changing their workflow and making it more difficult for them to do their job? How is it going to make it more easy for us to say, this is valuable, and not just because we have to be compliant? And when we reach that stage where someone goes, I'm not going to make this mistake because it's going to make someone unhappy or it's going to affect their lives, then we will reach that turning point. And I think that's an awareness thing, because like as you said, a lot of devs may not have even seen this in the wild. There's a funny story I tell about SQL injection. I was training students in university, and we give them a little thing to do, which is like build a hotel reservation system, a basic CRUD. And you get all the kind of students up, and they show you their program and everything. And the first thing I do is do O apostrophe, because that's an Irish, like O'Malley or Driscoll or whatever. And you'd always find the people that had someone with O'Driscoll or O'Malley in the system, because they would know how to escape that. So if you want to avoid SQL injection, hire an Irish person. But it's, the thing is that they didn't understand why they were doing it. They just know it caused an error. So I'm hoping that maybe it's awareness within companies, like showing that this is wrong, you need to do this is a dark pattern, the anti-patterns, like we will see that hopefully evolving, and as more stuff comes in. It's also very hard to shoot yourself in the foot now, like with ASP.NET doesn't allow you to kind of turn off a lot of the security features, because it makes it, are you sure, are you really sure?
ASP.NET Core, you cannot get it to not print out the warning messages if you've turned off data protection and,
Oh, really?
and encryption for your machine keys and things.
And I think the point you made about UX and the evolution we've seen in that area is interesting. How many of you here have ever had a story on your backlog that says, as the user, I want to enter my password? Yeah? And how many of you have ever gone, ooh, I want to enter my password, I'm the user? They don't. No one wants to enter a password, you know. And we have these stories that make it into backlogs, which are just this blinkered thinking. The two things the user wants, they want their stuff, and they don't want anyone else seeing their stuff. Those are the actual requirements in terms of building, usable systems that people actually want to engage with. And when you start thinking of security in terms of those things, one of the workshops I do, I have, you know the Bond movie where he escapes from the prisoner of war camp? And he walks into this hotel in Shanghai, and he's got his massive beard, and the concierge just goes, good evening, Mr. Bond, your usual suite? You know, that is the ultimate authentication. It's, recognition and personalized services being offered based on biometric parameters. He hasn't had to produce some ID or anything. That's the kind of security system we should be aspiring to, not longer passwords. We should be thinking, how do we build systems that are secure, that are personalized, that are friendly, welcoming, not make the password stronger. No, make it weaker. People don't like long passwords. No, make it stronger. People are going to get cracked. No, make them require an uppercase letter and a lowercase letter and a cat emoji and a this and a that. And
it's not even a thing anymore,
yeah.
according to OWASP.
Yeah.
I think that there's a different problem that we face, though. While all these little isolated offers do make things more secure, the default behaviors of ASP.NET Core, the new visibility into what's going on, and APIs would be another one. API security with API management, they will do token validation for you. There's still cases where you need the token to flow through, though, because you need to know who the user was. You need to identify them and go look up their permissions. So it's not a perfect answer, but it is an answer for some people. The challenge is that there's so many layers of security issues, from the security awareness trainings companies need so that people don't click the wrong links in an email and open an attack and leave their computers open, to the actual software architecture in the infrastructure in the cloud, to how we handle secrets, to how we secure APIs, to how users log in, and using protocols like OpenID Connect that at least gives us an out-of-the-box, if you use components that work with that protocol, out-of-the-box security with ASP.NET modules, that integrate, and also it reduces some of the threats for the login workflows. So the problem is people take that and then they say, I'm done, and then they start building custom workflows around registration, and they send passwords and email, and they do this and they do that because they don't know all the security rules. Yeah. So, security's hard, software's hard, and people have to invest in it more than ever from the beginning, and startups don't have that kind of money, so there's still going to be lots of mistakes. You just have to remember that, you should always be trying to bring in, hopefully, guidance. You're not going to be able to learn it all yourself. You have to bring in people that know each of those layers to help you succeed, in order to avoid.
That's a very important point,
right.
Because even if we look at what I talked to Brock Allen on OAuth. It's just if I don't need anything else, I talk to him. If I talk to Scott Helm when it comes to certificates, because these are very specific people. They know what they're doing in that area.
Exactly.
Even all across all the security spectrum, it's too broad. It's like saying I'm a cloud architect and I know all the cloud platforms and all their idiosyncrasies, and you'll go, liar.
You can't be an Azure expert, you can't be an Amazon expert, you can't be a security expert. It's too blanket.
Yeah.
You can be an expert in some things of each of those.
And be very good at the other parts.
Excellent. All right, well, thank you very much. And thank you, everybody, for coming to the very first American Hello World live show. Thank you again, Minnesota. Make sure to see us. You can find us on the.hw.show to find more of our YouTube videos and our interviews. And thank you very much.
Let's give a hand for our great panelists.
Yes. Have a great rest of the conference.